Last week's video vanished. And yep, that's on me. I filmed the 100-meter pressure test with my phone, ran out of memory, and like a true villain, I deleted the masterpiece forever. But good news, I've upgraded to an action camera with a giant 1 terabyte card. No more oops moments. Lesson learned. 2 years ago, I built a small ROV, basically a little underwater robot, for kids at school to try out and experience the fun of piloting. It was meant as a playful introduction to underwater exploration. Now, after 2 years, the polycarbonate watertight cylinder has aged and finally cracked. So today, I'm giving it proper repair. I prepared a brand new watertight cylinder, ready to replace the broken one and bring this little ROV back to life. First things first, cleaning the inside of the watertight cylinder's end cap. Because, let's be honest, nobody wants mysterious release agent hanging around in there. Next, I take the 3D printed mounting plate for the internal equipment and, with the elegance of a DIY surgeon, I temporarily glue it into place using fast-dry adhesive. Quick, simple, and just sticky enough to hold, at least until the real action begins. Now it's time to pull out all the electronics and batteries from the old watertight cylinder. And here's the twist. There's only one waterproof connector for the surface signal buoy. Everything else, it's soldered and sealed solid with epoxy resin. So this repair isn't just a quick swap. It's almost like building a brand new ROV from scratch. Complicated? Absolutely. But hey, that's the charm of underwater DIY engineering. It's finally time to say goodbye to the cracked watertight cylinder. A farewell ceremony, DIY style. I gather up the broken pieces, salute their 2 years of loyal service, and then toss them straight into the trash can. No tears, no drama. Just the sound of plastic hitting the bin. Out with the old, in with the new. That's how underwater engineering keeps moving forward, one broken part at a time. Oops. The old watertight cylinder isn't completely useless after all. Sure, the body is cracked and retired, but the acrylic dome at the front, that part is still perfectly fine and ready for a second career. So instead of throwing everything away, I rescue the dome like a treasure from the wreckage. It gets cleaned up, polished, and prepared to join the new cylinder. Recycling at its finest. Engineering style. Because in DIY, even broken parts can have a comeback story. Now it's time to prepare the watertight cylinder properly. I sand both the inner and outer edges of one end, not to make them smooth, but to roughen them up. Rough surfaces give the epoxy resin something to grip onto, like traction for glue. It's a small detail that makes a big difference in bonding strength. Then comes the clever trick. Inside the acrylic dome, I add a 3D printed circular wall like a miniature dam. Its mission is simple. When I pour in the epoxy resin, this barrier stops the resin from flowing into the dome's transparent viewing area. Without the wall, resin would creep into the clear section, clouding the window and ruining the view. With the wall, the resin stays exactly where it belongs, locking everything in place while keeping the dome crystal clear. One little dam, one big win for underwater engineering. Pump it, pump it. I pump epoxy resin right into every gap. Fast, simple, and oddly satisfying, like giving the ROV a high-tech energy drink. Once the resin is cured, I get ready for drilling. Short, sharp, and straight to the point. Now it's time for the tedious chores. Drilling holes into the new end cap, stripping the wire insulation, tinning the copper cores with solder, and sanding the wire surfaces. It's not flashy, but these little steps are what make the whole system tough enough to survive underwater. By the way, this little wooden block, normally used for jewelry work, is surprisingly handy for sanding wire insulation. Cheap, simple, and honestly, It feels like the perfect hack for DIY engineering. Now comes the wiring marathon. Each cable gets carefully threaded through the new end cap, one by one, like lining up runners at the starting gate. Once they're in position, I lock them down temporarily with a few drops of fast-dry glue. It's quick, it's neat, and it keeps the cables from wandering off while I finish the rest of the build. It may look simple, but threading and fixing dozens of wires is a patience test. Think of it as cable choreography. Every wire has its place, and the glue keeps the dance in order until the grand finale. Next up, drilling holes into the equipment mounting plate. Each hole is measured, marked, and drilled with care, like setting the stage for a new cast of characters. Once the holes are ready, the electronic components move in. One by one, they're installed onto the plate, turning a plain piece of hardware into the control center of the ROV. Simple steps, but they bring the whole system to life. So here's the mystery item. Who knows what this is and what it's actually used for? If you've got an idea, drop it down in the comments. I'm curious to see what kind of answers show up. Sometimes the audience knows more than the engineer. Back to the soldering bench. It's time to keep joining wires together. Steady hands, neat joints, and the connections line up one after another. Fresh out of the 3D printer, the new parts are ready. They replace the broken ones and slide neatly back into the ROV frame. Now comes the most critical step, pouring in the epoxy resin. This is my budget-friendly way to seal ROV cables. Think of the watertight cylinder's end cap as one giant cable penetrator. Borrowing Blue ROV's term, instead of dozens of individual penetrators, I simply pour resin into the end cap, encapsulating nearly all the cables at once. Cheap, direct, and effective. I ran a quick test on the battery, and the results weren't pretty. The pack is basically dead. So I opened it up and checked each individual cell with a multimeter. Some cells still had a little life left, but a few of them showed absolutely no voltage at all. Flatlined. That's the risk with these packs. Once a few cells go bad, the whole battery becomes unreliable. You can't trust it to power an ROV when half the cells are ghosts. And honestly, trying to revive them would be more trouble than it's worth. So the conclusion is clear. This battery is done. The only real solution is to build a new one from scratch. That means sourcing fresh cells, balancing them properly, and assembling the pack with care. It's not just about replacing dead parts. It's about making sure the new battery is safe, stable, and ready to deliver consistent power. It might sound like extra work, but in the long run, building a new pack is the smarter move. Better to invest the time now than deal with failures later. So, farewell to the old battery. It served its time, but now it's time for a fresh start. I really enjoy using a spot welder for battery work. In just a split second, a clean weld is finished, and sometimes you even see tiny sparks flying. It feels surprisingly satisfying, like a little victory each time. There's something about the speed and precision that makes the process addictive. After the welding is done, I don't just stop there. To really test the pack, I hook it up to a 775 brush motor. That motor is a beast. It draws a huge startup current, which makes it the perfect stress test for any battery. If the pack can handle the 775 without breaking a sweat, you know it's ready for serious work. And finally, the finishing touches. Slide on a heat shrink wrap to give the pack a clean look, then seal the ends with insulating glue. It's neat, it's safe, and it makes the battery feel complete. From sparks at the welder to the roar of the 775, the whole process is a little journey. And the result is a battery you can trust. Finally, the new battery is in place, installed and ready to go. Next, it's time to install the O-ring onto the end cap. But don't forget the basics. Wash your hands first, then apply silicone grease to the O-ring. And here's another important step. Spread a thin layer of silicone grease on the inner wall of the watertight cylinder's port. Skip this, and the O-ring will almost certainly get damaged. Careful prep now saves you a lot of trouble later. Let's slide the end cap into the watertight cylinder. Don't forget to vent it. The little car tire valve core I mentioned earlier is here to release internal pressure. 4 pool depth educational ROVs. This cheap and simple trick works just fine. Now the watertight cylinder is mounted into the ROV frame. All the bolts are tightened, and it's time to adjust the balance. The previous cylinder was thicker, which gave more buoyancy. This new one is slimmer, so I need to reduce the ballast weight to keep everything stable. Once the adjustment is complete, the ROV is packed up and ready to ship. I hope you've enjoyed watching this build. Please like, subscribe, and hit the notification bell. Your support means a lot to me. And for the next video, we're leaving the water behind and heading to the sky. A small repair project on a DJI drone. Stay tuned.